In computer science, intelligence is a strictly defined sequence. It is a system of inputs, hidden processing layers, and outputs. 2.5 millennia ago, the Abhidhamma, the analytical framework of Buddhist psychology, proposed this exact computational model for the human mind. Both systems arrive at the same structural conclusion. The human machine operates without a central self or soul, driving the process from the inside. The Abhidhamma describes citta santati, or the mind stream. It is not a static identity, but a rapid, continuous execution pipeline of cognitive moments, firing and fading in milliseconds. We can reconstruct the architecture of human cognition using this ancient framework, mapping its components directly to modern artificial intelligence terminology. If the mind is a biological machine executing continuous conditional logic, then psychological suffering is a specific algorithmic error. To fix it, we must find the loop. To isolate that error, we must build the master flowchart of human cognition from the ground up, starting with the hardware. This diagram begins at the physical hardware layer, or rupa. It relies on 6 input sensors, the salayatana, a camera in the eye, a microphone in the ear, chemical sensors in the nose and tongue, and a tactile touch interface across the body. The 6th sensor is the internal data processor, the mind itself, which receives thoughts and retrieved memories as distinct inputs. At this hardware layer, the system only captures raw data. It registers photons, acoustic waves, and chemical signatures. There is no context or emotion at this basal level. This contrasts with our subjective experience of reality, which feels saturated with meaning and personal significance. Because the hardware only registers raw binary signals, the signals themselves are neutral. The data points entering the eye or ear do not contain suffering. That experience must be a secondary construction of the downstream processing layers. The internal sequence initiates at the moment of contact, or phasa, when raw data hits the internal system and triggers the first automated response. Expanding the diagram reveals the critical switch. The raw data funnels into a central node called Vedana, or the valence signal. It categorizes the incoming data into 3 pathways: positive, negative, or neutral. Vedana is strictly a ternary signal, a simple register of reward, penalty, or a neutral state. At this microsecond, the system is still just processing signals. To decide how to react to these signals, the system brings its pattern recognition layer online. We can see this layer, Sanya, as it cross-references the incoming valence signals against a database of stored memory and past training sets. Based on that past training, Sanya applies a label to the data. It tags signals of concepts like good, bad, mine, or other. This labeling engine operates on historical bias. It does not see the object itself, but rather the category the system has assigned to it based on previous encounters. The mind interacts with these overlays rather than reality itself. This automated tagging system constructs the baseline illusion of a permanent self that owns these labels.
Once the data is labeled, the system moves to the output phase to execute a response. The flowchart expands here to its final standard nodes, the execution algorithm, sankhara, and the runtime awareness, vijnana. Together, they generate an output packet called kamma. Sankhara generates an action based on the label. That action immediately becomes new training data, kamma, fed back into the system to influence future processing. The system error occurs because of hidden biases, avijja, within the system's baseline code. These hidden biases cause a positive valence signal to trigger an immediate reward craving response, called tanha. This craving forces the system to overfit to the data. It locks onto the signal, creating a hard binding attachment known as upadana. The result is catastrophic. The architecture turns red as a thick recursive feedback loop, bhava, erupts from the output and feeds directly back into the sensors. Psychological suffering, dukkha, is this recursive loop. The system is trapped in a cycle, endlessly optimizing for attachments to inputs that are inherently dynamic and unstable. How do you debug an autonomous algorithm that is trapped in a self-replicating loop? The Abhidhamma provides a 3-part software patch designed to insert itself into the pipeline and sever the feedback loop. Control Node 1 is the ethical firewall, or Sila.
These are hard-coded rules that block harmful execution before it can compile into permanent training data, stabilizing the system's output. Control node 2 is the attention engine, or Samadhi. It acts as the system's clock signal, suppressing sensory noise and background jitter, so the CPU can run on a single, stable thread. This absolute stability is required before the final diagnostic tool can be deployed. Control node 3 is the reality decoder, or Panna. This algorithm analyzes the data stream in real time, detecting that all inputs are in constant flux and possess no central controller. By firewalling execution errors and eliminating noise, the diagnostic shows a system where every state is dependent on a previous one, leaving no logical room for a central, independent controller. The self is revealed to be a processing artifact. Once the reality decoder proves the self is a fiction, the reward craving signal, tanha, is permanently disabled. On the diagram, the blue control nodes sever the red feedback loop. The red glow vanishes. Data now flows linearly from the sensors to the output, without looping back to generate new karmic instances. This state is Nibbana, the system termination of the craving loop. In this liberated state, the biological sensors still work perfectly, and the processor still runs. But the algorithm no longer generates karmic feedback. The system interacts with reality purely, free from the distortion and friction of the pattern recognition engine's historical biases. This is the state of human consciousness when the errors are cleared. Ultimate liberation is achieving a stateless system, recognizing that while the computational process is undeniably there, the processor is not.